Hello and welcome. Today we're doing a question from LeetCode called Max Area of Island. It is a medium. Let's get started. Given a non-empty 2D array grid of zeros and ones, an island is a group of ones which represents land, and it is connected four directionally, horizontal or vertical. You may assume all four edges of the grid are surrounded by water. Find the maximum area of an island in the given 2D array. If there is no island, the maximum area is 0. So in our example right here, we see that we have a bunch of zeros and ones, and our answer is 6, which is this island right over here. 1, 2, 3, 4, 5, 6. We have a few other islands. This is just one. This is from here to here, an island of 4. There are a few more, 4 going this way right here, so 2 here, 3 down, 5 over here, and 5 over here. But of course, the max area is 6, formed by this bolded 4 shape right here. And example 2 is just a grid of all zeros, so of course, for that we return zeros. This question is actually very similar to one I've done before. If you've seen number of islands, try to do this question yourself. We just have to change one thing and we'll get the answer we need. If you haven't seen it, I have it linked in my description down below. Check it out. If not, we're gonna jump right in. So the intuition for the maximum area is we want to do a depth first search. As soon as we hit a 1, we want to see how big the island is. So we want to search in our 4 directions, up, down, left, right, and add up the area. So over here, this is just 1. We're assuming, anything out of bounds is 0, so it's water. We don't add anything to our land. Over here, we do a DFS from this index, search bottom, right, right, and we should output 4. So what we're going to be doing is iterating through the entire grid. As soon as we see a 1, we perform a DFS, see how big the island is, calculate the area, and return that. Additionally, we also want to maintain some sort of seen value. So if we've already seen a 1 part of another island, we don't want to visit again and perform another DFS. So for that, we can actually mark seen in place by just getting rid of the 1s, converting them to water or to just zeros. That way we know we don't have to search through this again. Once we iterate through the entire grid, we'll have our max area and simply return that. So going into the code, we'll explain a little bit more in depth as we go. So first we want to have the area of our island. So area islands equals 0. Now we want to loop through every index in our grid. So for r in range len of grid, for c in range len grid 0. So what I'm doing is looping through all the rows and columns. So this is going left to right, top to bottom. If grid of RC equals 1, if it is a land, then we want a function to count the area of that island and return that value while also marking everything as 0. So let's make a helper function for that. What I'm going to do right now is have area islands equal max of my current area islands and what my helper returns. So solve.dfs of grid RC. This is going to be returning an area of the islands. So that's all we do. And once we are out of this loop, all we do is return area islands. This is relatively simple enough. Now for the fun part, we're going to write our DFS. So def DFS takes in solve, grid, row, and column indices. The first thing we want to do, as we are, for example, on this island right here, we are going left to right, up to down on all the grids, or all the indices. So we'll hit this top index first, the first thing we want to do is mark it as seen. So grid of that index now equals 0. It's water. Now we'll know not to visit this again. And we also want to have the area. So the area is always going to be initialized to 1. This is just a land with an area of 1. We wanted to check the 4 directions, so up, down, left, right. Let's make a list for that. So this is going to be R minus 1C. This is a row above with the same column, so this is exploring the top. Then row plus 1C, bottom. Row C minus 1, this is going to the left. And row C plus 1, going to the right. So for the row column in list, we now want to see if they are lands and within our grid, because what if we're over here? The top here doesn't really matter. It's out of bounds of our grid. We know it's water. So we're going to have an if condition. If row greater than equal to 0 and column greater than equal to 0 and row less than len of grid and column less than len of grid 0, and the next index we are exploring is actually land. So grid row column equals 1. Then we add to our current area whatever we get from that DFS. So all we have to do is make a recursive call to DFS with grid row column. At the very end, we return none. So looking at this example over here, we are at this index, which is 0, 1, 2, 3, 4, 5, 6, 7. We are at 0, 7. We have marked this as 0, and our current area is 1. We explore the top, bottom, left, and right. Of course, top is 0. So in this for loop, we don't make it into the if condition. We come back around. Now we check bottom. It's going to call the DFS. So right now we have num plus whatever that DFS of the bottom is. So essentially it's num, which is 1. We're going to add on whatever our DFS of this bottom returns. So we haven't finished this. This is still in our stack. It needs to wait on the bottom now. So as we now call the bottom, we check top. But since we had zeroed it out when we had called the top first, we know this is 0 and we skip this. Check bottom, 0. Left, 0. Right is not 0 though. So now this is going to be 1 plus whatever the DFS returns from the right. We do the same thing for the right. Top is 0, bottom is 0. Left had already been visited, so we had changed that to be 0. So it's 0. And we return 1 plus whatever is on the right. The right will have seen everything zeroed out. It returns 1. It returns num. It never even goes into the if condition. So now we have 1 plus whatever this DFS had returned, which was 1. So here we have seen 2. But what had this called? It had been called through here. So this is now going to be 1 plus its DFS call, which was 2. So this is 1 plus 2 equaling 3. We pop back up from the top. This had been 1 plus the DFS call of the bottom, which now stores 3. So 1 plus equals 3 equals 4, and we return 4. That's how the areas are being calculated. And each time we zero it out, so we'll never double count anything. Then all we do is take the max of all the areas we've seen and return that. So let's run code. Accepted, and let's submit. And it is accepted as well. So talking about space and runtime, our space, although we do all our modifications of scene in place through the grid itself, because it's a possibility that we could have had an entire grid filled of 1s, our DFS waits for itself before it can go off the stack. So right now, if we had seen, for example, this one, right? It couldn't finish until it had finished all of its DFS calls. So we could be holding the entire grid in our stack memory before we pop back up to the original caller. That's why space is m by n, or m times n if this is an m by n grid, 2D array. And our runtime is also m by n since we iterate through the entire grid, all the indices there. So this is m by n runtime and space. Let me know if you have any questions. I'll see you next time.